Today we will be starting our last topic of AS physics, that is waves. We just finished electricity, and this page right here is from Paers and Edexcel website, and you can see they have given us a list of the concepts that we need to cover. We will be following this list. In this video, we'll cover these first two concepts. So you can see some basic definitions, and we will be using this first equation for this chapter, V equals F lambda, to solve this first question. I've chosen this basic question to start this topic because this is the first video of this chapter and I want to start from the basics. So let's read the question first. We have a light source which is emitting light waves, and this process lasts for 0.04 microseconds. The light wave has a wavelength 600 nanometers and the speed of light is also given. What we have to find is how many complete waves are sent out. Now, if you're already familiar with this equation, V equals F lambda, you should understand that this question is not simply asking us to calculate frequency, right? Frequency is defined as the number of waves in 1 second. On the other hand, in this question, we have to find the number of waves that are sent out in this time, not in 1 second. So this is not simply finding the frequency, okay? So if you understand this equation, you can skip the video, you can wait for the more advanced questions. But since this is the first question, I will start from the basics, and the basics that we need are some definitions. Let's draw a wave first of all. So x-axis on y-axis, we'll have some wave that looks like this. And let's just assume that my drawing is not that bad and all of these points are at the same height. And similarly, on the negative side, they are at the same level. Now, the first thing that we want to define for this wave is this symbol lambda, which is representing wavelength. So wavelength for a wave is the distance of one complete wave. One complete wave, if you're starting here at the origin, one complete wave will be this point right here. So this complete mountain and this complete valley, this is one complete wavelength. On the other hand, if you're starting, for example, let's say here at this point, one complete wavelength will be the distance between these 2 points. So this is also wavelength lambda. This is also wavelength lambda. And you can also measure the wavelength from this point to this point. So all of these are the same lengths, and this is called wavelength lambda. Next thing is frequency, F. Frequency is defined as the number of complete waves in 1 second, okay? And frequency is measured in the units of hertz, Hz, or hertz can also be written as inverse second. So because it is just the number of waves per unit time, number of wave is just a number and you are dividing it by time, so that's why the units will be just inverse time or inverse second, which is also called hertz. Finally, this V is the velocity of the wave. And if you have an electromagnetic wave, because electromagnetic waves travel at the speed of light, so we usually write this V as c if you have an electromagnetic wave, where c is the velocity of light, which is 3 times 10 to the 8 meters per second. So c equals F lambda. Now this is a very important equation that relates speed of the wave to its frequency and its wavelength lambda. Okay, so after understanding these 3 basic definitions, let's solve the question. The question wants us to find how many complete waves are sent out, right? In this equation, frequency is something related to the number of waves, right? But frequency is the number of waves in 1 second, right? Not in 0.04 microseconds. So we can figure it out if we can find frequency. And in order to find frequency, you can rearrange this equation. You can divide both sides by lambda. The lambda here will just cancel and you will have frequency equals to c over lambda. So using this equation, we can find frequency, and frequency will tell us how many waves are passing in 1 second, right? But we want to find how many waves are sent out in 0.04 microseconds, right? So our strategy is that if we know how many waves are sent out in 1 second, we can find out how many waves will be sent out in 0.04 microseconds by just multiplying the frequency with this time, right? So let's first of all find the frequency. Frequency will be just the speed of light, which is 3 times 10 to the 8 meters per second, divided by the wavelength, which is 600 nanometers. Now, I can also teach you a small trick to solve this expression without using your calculator. Most of you, I think, already can solve it. So what we can do is we can write the denominator, which is 600, as a power of 10, right? So 3 times 10 to the 8 meters per second speed of light, divided by 600. I can write it as 6 times 10 to the 2, and this nanometers can be written as times 10 to the power of minus 9, which is just the value of nano and meters. Now what I can do is I can simply work with these whole numbers 3 and 6, and I can work out these powers of 10 separately. So 3 over 6 is just 1/2, and times, I can write all these powers of 10, I can combine them. So I'll have 10 to the 8, and this 2, if I move it in the numerator, I'll have to change the sign. So it will be minus 2, and this negative 9 will be plus 9. And the answer will be 0.5, which is coming from this half. And the power of tens, if I work out these numbers, will be 10 to the power of 15. And the answer should be in the units of inverse seconds, right? So this is frequency, 0.5 times 10 to the 15 inverse seconds, or we can also write hertz. Now, in order to find how many waves are sent out in this time, we have to multiply frequency, which is the number of waves in 1 second, with this time, which is 0.04 microseconds. So let's see how can we find the number of waves that are sent out in 0.04 microseconds. This will be equal to frequency, which is 0.5 times 10 to the 15 and inverse seconds. And I have to multiply this with this time, 0.04 for microseconds. I will write times 10 to the negative 6 seconds. And you can see I can also work with this number so that I don't have to use my calculator. I can write 0.5 times 10 to the 15 times, I can move this decimal point 2 places, write it as 4, and then compensate for moving the decimal point by writing 10 to the negative 2, and then this 10 to the negative 6, which is coming from microseconds, right? And here I have inverse seconds, and here I have second. You will see that these units will also cancel. So second inverse and second both are canceling, which we need to cancel because we are just calculating the number of waves, right? So number of waves will be just a number. We don't need any units with it. Okay, so let's work out this. 0.5 is just 1/2. We have to multiply 1/2 with 4, which will give us 2. And you can work out the powers of 10 again, which will be 10 to the 15 minus 2 minus 6, which will give you 2 times 10 to the 7. And this is the number of waves which will be sent out in this time of 0.04 microseconds. You can see it's option A.